HIV is a virus that specifically infects humans and currently infects 37 million people worldwide. Despite global efforts to stop it, HIV and AIDS has led to the deaths of over 35 million people. HIV is spread from person to person through bodily fluids such as blood, breast milk, rectal fluids, semen, preseminal fluids, and vaginal fluids. The main cells HIV infects are the CD4 helper T cells. However, HIV can also infect other white blood cells such as macrophages and dendritic cells. Helper T cells mediate immune functions by releasing cytokines. These cytokines function as chemical messengers which facilitate cellular communication between cells in the immune system. Everything from healing paper cuts to fighting the flu requires cytokine signaling. With this in mind, it's easy to see why HIV can have such a devastating impact on the human immune system. Upon entering the bloodstream, the HIV virus will attach to the CD4 receptor on the cell surface of the T cell and then its co-receptors. The glycoprotein receptors on the viral surface are analogous to a key, while the CD4 receptors act as a lock in which the virus is able to open. Upon attaching to the helper T cell, the two membranes fuse and the HIV releases strands of viral RNA along with the enzymes integrase, ribonuclease, protease, and reverse transcriptase. These enzymes are required to integrate the viral RNA into the genome of the host cell and allow it to hijack the cell's machinery to produce new viruses that can then go on to infect more cells. The reverse transcriptase enzyme that turns viral RNA into DNA is highly prone to error. The cumulative effect of these errors is a massive rate of mutation. HIV undergoes more mutations during the first 10 days of infection than all of the strains of influenza have throughout human history. The vast number of mutations means that some of the HIV virions will not be recognized by the immune system, allowing them to evade detection. During the initial stages of infection, a person may not show major symptoms for up to 10 years. However, a person's CD4 count will eventually drop below 200 cells per cubic millimeter of blood. At this point, they are considered to have the condition known as AIDS. As a result of the low CD4 count, opportunistic diseases are more likely to infect and kill the person. While there is no cure, HIV can be prevented by practicing safe sex, clean blood transfusions, using sterile needles, and getting tested. Scientists have been attempting to develop antiviral drugs which target the enzymes used by HIV to infect cells. By blocking the activity of these enzymes, the rate at which HIV infects cells will be slowed down drastically, which can help people with HIV live longer and have healthier lives.